Thank you very much, everyone, for joining us today on our next webinar in the Zeek webinar series. The speaker today is Arne Welzel, who is one of the core maintainers of Zeek, who has worked on a lot of different parts of Zeek and done things like, implemented things like JavaScript support to Zeek. And if you have ever filed any tickets, there's a quite large chance that you've interacted with them. And he's going to talk about pluggable cluster backends today. So thank you very much and take it away.
Okay. Hello, everybody. Welcome to the webinar. This is, about pluggable cluster backends. It's going to be a bit different than maybe other webinars. So this is not about Zeek's functionality for users like analyzing packets or protocols and producing logs for analysis. It's more on the development and underlying side of Zeek, in particular about revamping the cluster communication. So this is still a project that's going on, and the first pieces have been merged with Zeek 7.1. But there's still more to do, but I wanted to give you a glimpse of where this is going. I'm relatively new to the Zeek project, so I might be missing some background and history or some decisions. I know that, so I needed to have an emoji for the slide. I know there was a library called Broccoli, so the Bro communication library, and that's about all I know about this project. So, just to jump directly into it, so from a context, if you run Zeek in a production environment, you run it as a multi-process application. So in contrast to Zeek-R, you usually have multiple processes. And these processes have roles. So there's workers, there's loggers, a manager, and then also proxy nodes or proxy processes. And I already used nodes. So we also call those processes cluster nodes. And cluster node doesn't necessarily mean that it runs on a dedicated system. So the cluster nodes can also be co-located on a single system. But as depicted here on that slide, it's also entirely possible that you have different sets of cluster nodes running on actual different physical machines, in which case they are then distributed. There's a requirement for those processes to communicate with each other, and they do that in terms of Zeek events. So, for example, if you analyze traffic and you want to do analysis so you want to aggregate information from all of the workers, that is usually done by sending Zeek events from worker nodes to the manager node. It's, for example, something that SumStats does. In another case where you need to have communication between those nodes is for the Intel framework. So the manager loads the Intel data file and then distributes the contained Intel indicators to all of the worker nodes to actually do the matching of the network traffic. Another sort of scenario where there's cluster communication involved is when you have an FTP control connection, and over that control connection, the data connection is announced. It's not guaranteed that the data connection goes to the same worker as the control connection. And then there's also sort of a broadcast in the cluster that a data connection is to be expected. And that's also in terms of sending Zeek events from one cluster node to the other cluster node. I'm mentioning log writing at the bottom. Log writing is separate from Zeek events, but it's also using cluster communications. So workers producing protocol logs would not directly write the log file to disk or send it to some other system, but instead offload it to logger nodes. In that graph here, there's one logger node. There could also be multiple ones. Okay, so that's the context. What the talk is about is sort of sending Zeek events or log writes among cluster nodes. So the communication model for Zeek events is basically, it's topic-based publish subscribe. So you express, or as a script writer or as a cluster node, they express interest in a topic where the topic is just a string or sequence of bytes that is shown on the right side in line 6, where there exists a function called broker subscribe. We basically express interest in the topic prefix. In this case, it's app/. And then on line 11, there's a broker publish call where you can also publish events from Zeek script to topics. In this case, it's app UIDs. And what's happening here is that the UID was, so for a new connection, the UID is published as a hello event to app UIDs, the topic. If you want to handle that event, you can see in line 15 to 17. It's just the same as you would handle a local event. There's no difference between handling a local event or an event that was received remotely. Yeah. So from the semantics, it's fire and forget, which means that if you do those broker publish calls for app UIDs and there's no actual subscriber in the cluster, or there's no other node interested in that topic prefix, then that message is black hole and doesn't go anywhere. Similarly, there's no persistence. So if you think of Kafka, you publish to topics in Kafka, and clients have offsets, so they can consume messages even when they were offline for a time, just by going back to the offset and starting to consume. That is not the case with Zeek. So if a cluster node goes offline and another cluster node publishes something to a topic, the node that's offline will not be able to see that message. Again, black hole, or there's no way to go back to that message to get it. Which it's a fairly simple model and doesn't put too much burden on the implementation of sort of persistence and state keeping. Okay, as mentioned before, logging is separate from events, but it's using the same communication layer today. There's sort of as an intro. Just to Johanna, I don't know where questions would show up. You just need to let me know if there's something coming up.
Yep.
Okay, perfect. And feel free to ask something if I should explain something else. Okay, so the implementation, what's in Zeek today, to realize that that publish subscribe functionality is called broker. So well, broker is not just a communication library, but at least in the context of this talk, it's a communication library, I guess. It's described as type-rich pub subsystem because it supports more than just publishing messages as bytes around, but it has some awareness of Zeek data types. It's essentially maintained by the Zeek project as a sub-project, and yeah, based on the C++ actor framework, or also CAF. Yeah, it maybe, yeah, at the bottom, so there was some communication mechanism for Zeek, for Pro back then, in 2. I don't know. So there was some communication mechanism, and in 2.Pro, 2.6, it was switched over to Broker in 2018. Yeah. Okay, and from how the connectivity is in a Zeek cluster with Broker is that, for example, on the right, you can see that all of the worker nodes peer with nodes of other types, but worker nodes don't peer with each other, which, yeah, so it's not fully meshed. And similarly, proxy nodes peer with manager nodes and logger nodes. But proxy nodes, so there's only one proxy node shown, but proxy nodes, if there were multiple ones, don't peer with each other either. But there's many connections going on. Yeah, within Broker, so those connections, the TCP connections, and the protocol that is running over those connections is basically a custom protocol by Broker. and also the serialization format used for the messages or from the Zeekish types to actual wire format is also a custom serialization format implemented in Broker. Yeah, and within Broker, there's quite a bit more functionality as well for other things like stores. And yeah, what's came in more recently, I guess, was access. So the communication between those nodes is a custom binary protocol. And in the recent years, a few years ago, there was WebSocket access added to the broker layer as well, where you can basically connect with an external application with a WebSocket connection to one of those nodes and then speak basically a JSON representation of the broker format of broker protocol with nodes in order to receive or publish Zeek events with external applications. Okay, that's it for an intro. So yeah. Why are we, so the title was pluggable cluster backends. So we sort of want to make this functionality pluggable or exchangeable. And the first question is maybe, why are we even looking at this? So this slide lists some non-technical issues that we have with Broker. So maybe the first one is that so Zeek as a software should be really good at parsing packets, interpreting protocols, producing logs that the user can consume. And Zeek, so the Zeek cluster, there is a use for messaging among the cluster nodes, and we want to leverage this, but it's not sort of the main thing where we want to add value. So it's not clear whether we need to invent and build our own messaging system. That certainly has some historic background why it was done this way, but maybe today one could reconsider looking at existing functionality. The second point is that so the broker code base and also the CAF code base, there's a limited talent available in the Zeek project that can grasp and work on that code. And yeah, the learning curve is fairly high to just get started with it and extend it or even just fix bugs. And then maybe sort of even taking a further step back, and that's very high level, but there's not many people out there that know about Broker very likely, or that would use it in their own projects. While I'm very sure there's Zeek users out there that have heard of ZeroMQ or that have heard of Redis and would be potentially willing to look into how Zeek is using one of those libraries, maybe even improving it, but might be sort of put off by seeing that we have our own library that they would need to get started with first in order to contribute. The other argument is maybe, again, sort of from an ecosystem dynamics standpoint, that we are fixing and we're extending Broker, but Zeek is the main user of this Broker project. So I don't know another application or big project that is using Broker, except for maybe some internal integrations with Zeek, but no Zeek independent project that would use it for messaging purposes. So extending it or fixing bugs really helps just the Zeek project and no other project out there. Well, if we would choose an existing project and potentially report bugs or even contribute features or bug fixes in an existing widely used library, that's sort of better for everyone, maybe. Yeah, that's a bit of a motivation why maybe it makes sense to relook into other systems. So from a technical perspective, it's and I don't know, this is sort of my pet peeve, and there might be a fix for it, but it's been discussed for many years and it hasn't happened. But anyway, so the issue is that it should be a generic publish subscribe system, but as a user, you're actually exposed to this cluster topology and how nodes are connected with each other. And the concrete example is that all of the workers subscribe to a topic, which is the worker topic. But when you publish a message from one of the workers to this worker topic, it doesn't actually arrive on any other node. It's sort of black hole. And the reason is what I said before is in the default setup, when workers are not connected with each other, they don't see each other's subscription. So what we even have in the documentation is that if you want to publish from one worker to all of the others, you need to manually relay through the manager, which apparently nobody really has complained about that before. But thinking about just generic publish subscribe system using topics, this is not something that you should need to worry about as a user. So yeah, that would be nice if another system could just provide us with that. The other thing is that, yeah, separately, that many things found their way into the broker layer, let's put it this way. So that there's all the connectivity and messaging and pub-sub system that's implemented there. But also, so before Zeek 7.0 and Tim moved the telemetry framework essentially out of broker into the Zeek layer. So there was telemetry, and yeah, Tim is also looking at sort of providing storage outside of broker, which is, yeah, currently broker also contains stores, and the WebSocket access to the cluster is also implemented in broker. So it's just I don't know, an accumulation of functionality that is hard to access for most of us. Yeah. And yeah, the last point is that Zeek provides plugins which allow plugging in functionality or exchanging certain functionality. And that's not something that broker has currently. It also was never a requirement, so that's probably okay. But for example, the serialization format that's used within broker, it's without changing something in the broker main code, you cannot try another serialization format, which is a bit unfortunate. Okay, so from there, the idea was to make it possible to make the functionality that broker provides pluggable. The main reason is so there was no way that we would sort of remove the pub-sub functionality that is provided by broker, just remove it and replace it with something else. Broker has been developed since, I guess, the years, since sort of 10 years, and then defaulted to in 2018. So it's tested and it works. And anything that we would build new will also have issues initially. So yeah, we that, and the other thing is that it should be easy for providing separate or different implementations for cluster functionality without adding without needing to maintain them in the Zeek tree. So it would be perfect if you can have a separate plugin that you load with Zeek and then be able to switch the whole cluster backend communication to something else using another library. And so to enable that, as I mentioned, Zeek already provides a plugin system, and to enable that, the direct step or the logical step was to add new plugin components in order to support cluster functionality. And in that, I'm not going to talk much about this event and log serialization components here, but that was also done in that step in order to make event serializers and log serializers pluggable, allowing you to try different formats or different libraries for serialization and not fixing it to one specific one. Okay. Yeah, so the last line is a bit simplified, but the idea is there's now a backend option or backend variable that you can redefine. And by default, it's the cluster backend broker. If you redefine it with some other backend, in this case, it would be ZeroMQ, then Zeek will instantiate the ZeroMQ backend instead of the broker backend. And all of the cluster functionality will be done with that. That is simplified because there's still some connections set up and policy scripts that are specific for ZeroMQ, but these already exist for broker too. They were just much in the base scripts. Okay. This slide is if you wanted to build your own cluster backend, so if build a plugin that provides the functionality, this is the interface that you would need to implement. And the first two ones are probably the more important ones. So publishing an event and publishing log writes. There should be nothing surprising if you have used the PubSub library before. There's a topic and there's the format describes how the buffer is encoded. And then there's the buffer which represents the message. And you use the library to then, or you use that buffer and send it out on the wire. Similar for log writes. And the do subscribe and do unsubscribe are to set up subscriptions and tear down subscriptions again. The ones that are not bold are mostly lifecycle hooks for when Zeek starts and Zeek stops. What you don't really see in this API is the receiving parts of events, so that when the publishing is sending out an event to other cluster nodes, but then receiving and processing an event isn't really represented here. For receiving and processing, there are helper functions, but the actual mechanism how you get a message from a certain library is very specific, and there hasn't been a good pattern extracted yet. So sometimes you get callbacks, sometimes you pull in some socket, but that is custom to the backend. Yeah. So I'm going to the next slide. Yeah, on the scripting layer, the first or second slide showed that there's broker subscribe and broker publish. These are specific to the broker backend, and what has been done was essentially moving also publish and subscribe functions into the cluster module. If you don't change the cluster backend away from broker, then cluster publish will essentially be the same as broker publish. But when running a non-broker backend, then broker publish will not do anything and actually also create a warning whether you're not rather wanted to use cluster publish. So the idea is that you gradually would move from broker publish to cluster publish in your script. So the implementations that were tried for alternative backends, there's one done with ZeroMQ. I mentioned ZeroMQ a few times just because it's a popular library that is widely used, and also so libZeroMQ, I think, is available in all of the distributions that we are supporting, and that's what's used for the implementation. The publish subscribe functionality is realized using a xpub-xsub central xpub-xsub socket pair where all of the cluster nodes connect to. And with that xpub except here, one actually gets global publish subscribe. So a worker, what I mentioned as my pet peeve, a worker publishing to the worker topic, that operation now works because the xpub except this central point will distribute the message that you published back to all of the existing workers. Yeah, for logging, so logging with broker logging and events go over the same connections. In this case, with the ZeroMQ backend, the logging goes via push-pull sockets. So that's ZeroMQ's native round-robin mechanism, I would call it, or they also call it backline pattern. So all of the nodes connect with the ZeroMQ push socket to all of the loggers' ZeroMQ pull sockets, and then ZeroMQ takes over the round robin between the available logger nodes. In the graph that I've shown, or in the diagram that I'm showing here, there's only one pull socket, but there could be multiple, and then round robin would be done automatically. The nice thing about ZeroMQ is that it's standalone, so you don't need to have an external service. This xpub except socket pair here looks like it's external, but in the default setup, the manager will start a thread or starts listening on those xpub except sockets and start a thread to proxy between them. So yeah, and so that's actually part of 7.1. It's very experimental, but if you wanted to run it and try it out, you could load this policy script that's at the bottom of the slide, and then Zeek control deploy and report any bugs that you happen to run into. Yeah. The second backend that we were looking at is ZeroMQ is part of the Zeek's main source tree. The second one we were looking at is the Nuts, is a backend implemented using Nuts. So Nuts is a cloud native messaging system, so something modernish, more modern. And that one we are currently maintaining as an external plugin, so that it's not in the Zeek main tree, but external. And if you want to use it, you build the plugin and load it dynamically. So this is using the official Nuts C library, and for the publish subscribe functionality, using just core Nuts. So Nuts also provides persistence with the chat stream extension, but for Zeek's use case, the core Nuts is sufficient. And then, yeah, in the diagram on the right side, you see that all of the clusters just connect to Nuts and set up subscriptions on the Nuts server directly. For the logging, so with logging, there's always this question with the round robin mechanism. Nuts provides a native round robin mechanism called Nuts queue groups, where then the Nuts server decides which of the consumers will receive log rights. So in contrast to ZeroMQ or to broker, with this setup, you would be required to run a separate Nuts server. So it's not that Zeek is now standalone, but instead you have to operate this Nuts server. Where, well, for development, Nuts is really nice because you just start this Nuts server executable and it runs in an actual production system, but would probably require a bit more care. But yeah, if you have feedback for that, whether you'd be okay running an external service next to Zeek in order to operate it, that would be interested in hearing what people think about this. Okay. Yeah, but this is mostly a slide sort of food for thought. When just looking at the layout of the Nuts architecture again, where for log rights in particular, all of the workers send their log rights to the central Nuts server, just to then have loggers pick up the log rights from the Nuts server again and do something else with them, potentially forwarding to Kafka or another Nuts server. the question sort of comes up, why do we need Zeek logger nodes, or why would somebody even need to deploy logger nodes? Why couldn't they just use modify their application and consume logs directly from nodes? Similarly with ZeroMQ, so the pull socket that all of the worker nodes or all of the cluster nodes connect now in the ZeroMQ backend architecture could just as well be provided by a Python process or by some Go process or some custom process. There's nothing necessarily Zeek specific around it. Yeah. The next point is more of a detail that the broker, the schema of log writes was sent as one of the very first messages over the connections, and sort of notifying the other side of what the log schema looks like and what log writes are to be expected. That breaks down once you have disconnected cluster nodes, as it is with not so ZeroMQ. You cannot really send something as a first message. You might not even know when that other node has appeared or when it reappeared. You might not get notified about it. And the way that's solved right now is that the log writes are always sent around in the cluster as batches, and the batches now have the schema prepended. That's a small overhead, but yeah, in a real life system, those batches are pretty large. That the header overhead is minusculous. Okay. As a last point, I mentioned the native mechanisms of nuts and ZeroMQ for round-robin mechanism. If you look at the broker implementation and its logging round-robin mechanism, there's lots of configurability and scriptability. And essentially, right now, I took the stance and said this can all go. We take the native mechanisms provided by those systems. And I think that's okay. But there's also feedback welcome whether people think differently. Okay, and that is sort of closing now. There's more things to do. This is sort of in the beginning, but we are making progress. So the immediate next step is to have the WebSocket support lifted into the Zeek layer out of Broker. Currently working on that. Broker is currently not really a cluster backend because there are existing code paths that we weren't really comfortable touching, and it's fearing that we would break something. As a bit of a exotic feature around adding metadata to remote cluster events that should also become better. Then the serialization still uses the broker serialization format. Just so essentially, when switching to ZeroMQ, you use ZeroMQ for communication. That is what's used, but the format of the messages is still the classic broker format. And there's, not very high on the list, but it would be nice to explore protobuffer cut and proto, or maybe do some compression of those messages because the broker format is rather bloated. That could also happen in a plugin outside. So there's nothing that, given that the serializers are also pluggable now, you could implement a plugin with a new format and then load it and see whether performance becomes better or not. You don't necessarily need to patch something within Zeek's main tree. And then, so ZeroMQ, if you use the ZeroMQ backend, it's currently running without encryption because that's the default. But there's ZeroMQ curve, and it probably makes sense to have some options and enable that if people wanted to use encryption. It's particularly interesting for multi-machine clusters. And real-world testing. So I tested the Zeek Cuttle on a VM, replaying some artificial traffic, but this code still needs to be tested on actual real traffic. Steps for you. So I mentioned a broker to cluster transition, basically switching everything from broker publish to cluster publish. That would make sense if you wanted to use non-broker backends in the future. Testing is always welcome. And then if you have your own favorite messaging technology, you could build a plugin or a Zeek package with the plugins for it. Yeah. Okay. And yeah, summary questions. So summary, well, we are making Zeek cluster communication pluggable, and there's more work to do. And I'm happy to answer any questions if you have them.
Thank you very much. I'm not sure if you see the chat, but there already are 2 questions. The first one is, any insights into performance differences between the cluster backends you have tested versus Broker?
No. I did sort of eyeball ZeroMQ versus Broker, and that I think Broker was a bit faster, but it didn't really shock me too much. So it was not a huge difference. I'm currently looking at moving the WebSocket layer up, or the WebSocket functionality, and so the first version that I implemented was really bad. Broker performs really good with WebSockets, and yeah, it's not. It doesn't magically get faster just by using something else, definitely.
Okay, thank you. And the second question is, any gotchas that you found about the architecture or data that might need changing when exploring these new backends, in addition to some of what you mentioned in the presentation?
I'm not sure I understand the question.
It's just in chat. In essence, was there anything unusual you stumbled across while implementing this? Would be my interpretation.
So okay. So the one thing I mentioned was the tight coupling between workers and loggers, and them exchanging the format of log streams. But it's more of a Zeek architecture. So those processes were basically too tightly coupled. So we don't want to have Zeek script writers necessarily make changes that just work as it always has. Or maybe a bit in the direction the serialization format used by Broker right now. It's not so it doesn't encode enough information to be able to go into different formats. So concretely, if you have a Zeek record on the script layer, and you have a Zeek vector, they are encoded in the same way within the Broker serialization format. You basically need to again know what to decode them into. And that is something around the serialization formats that I think would be nice to improve, to make them to make it clear this is actually a record and this was a vector, so you can go into different formats without needing to have Zeek scripts to interpret the format. I'm not sure that was something you were hoping to hear, Vince. But
okay, does anyone else have any questions? If you have questions, you can either raise your hand and we can unmute you, or you can write them into chat or into the Q&A section. I'm going to give this a couple of seconds for people to decide. Okay, in that case, thank you very, very much for your talk, and thank you everyone for attending. And I think we have our next webinar planned. I should have had this ready on the 5th of February about the Zeek telemetry framework. So hopefully I'll see all of you there. Thank you very much and see you soon.